In today's video we're going to look at the electrolysis of solutions. In the first case we're going to look at the electrolysis of sodium chloride, and then we will look at the electrolysis of copper sulfate. This is my setup. I'm using a power pack with a DC supply coming from the positive terminal. I've got red wires and these are connecting to our copper electrode. Now the positive electrode is called the anode. Our black wires, as you follow them round, coming to our carbon electrode here, this is called the cathode. We have to use DC, otherwise we will not get any electrolysis occurring. The bulb will indicate that we have an electric current passing through. I've turned on the current now, and as you can see the bulb is lighting very gently, showing that we have an electric current flowing through. And if we look at the electrodes, we can see what's happening in the reaction. As we can see, the electrodes, we're getting gas being produced. It's much faster at the cathode than is the anode. I'm going to add a little universal indicator to both sides. Now, as you can see, at the cathode, it's gone purple, which indicates that it is an alkali. Whereas at the anode, for starters, it goes red, showing we've got it's acid. And if we stir it, now that colour disappears. And that's because we're getting chlorine produced. Chlorine will bleach the indicator. So, two gases, chlorine at the anode, and the gas that we get at the cathode is hydrogen. And we're also getting an alkaline solution forming as well. So let's look what's happening in this solution. So the positive ions both move towards the cathode and the negative ions both move towards the anode. Now obviously, as we've seen hydrogen produced, sodium isn't released. Now if we've got a hydrogen ion to form hydrogen gas, it's got to gain an electron, and hydrogen gas we know is H2, so we need two hydrogen ions and two electrons, and this is called reduction. If we look at the anode, we've got chlorine released. Now chlorine's a negative ion. Become chlorine gas, it's got to lose an electron. And chlorine gas we know is diatomic, so it's Cl2. We need two chloride ions and we need to lose two electrons. Now why is it alkali in solution? Well, very simply because the sodium ions and the hydroxide ions, which aren't released, are forming sodium hydroxide. That's why it's alkaline. Now the second part of my video now is electrolysis of copper sulfate. Now I'm going to do this with both carbon and with copper electrodes, and we'll see if there's any difference between them. Now the first one I'm doing is aqueous copper sulfate with carbon electrodes. As we can see here, you can see we've got a current flowing because the bulb is alight, and this is due to the movement of the ions. This is the cathode, this is the anode, and we'll run this a little while to see what's happening. Now at the start, our carbon electrodes looked exactly like this, just pure black. And we'll just run it just a little bit longer, and then we'll look at our electrodes. Now, in terms of observations, we can see that we've got a gas being produced at the anode. Now, if we look at the cathode, we can see the cathode has got this reddy brown deposit on it, which is copper. Now, if we look what happens here, please. Copper and hydrogen both move towards the cathode. Copper is the least reactive, so copper will be released. So, for copper to be released, it must gain electrons. 2 electrons, and this, as we know, is reduction. At the anode, hydroxide and sulfate both move towards the anode, and as we know, hydroxide is released. Now, the equation for the release of hydroxide, if you remember, is 4 hydroxide ions go to 2H2O plus our oxygen and 4 electrons. And we can tell the copper is released because we've got, it goes reddy brown. Now, if we think what's happening in solution, what's been left in solution is this hydrogen and sulfate ions. So this would form sulfuric acid, which we know is colourless. So if we ran this electrolysis for several hours, we would lose the blue colour and we get a colourless solution. And this time here is our electrolysis of copper sulfate using carbon electrodes. We get a completely different reaction this time. Now, if I zoom in, as you can see, there's no bubbling this time. We do have a change on the electrode. So, if we look at the cathode, so we can see we've got this pink deposit of copper. Now, where does this copper come from? The copper has come from the anode. So if you look at the appearance of the anode is actually gets thinner. So the anode dissolves, goes into solution, and copper is deposited at the cathode. Okay, so let's explain what's happening. Again, both copper and hydroxide and hydrogen ions move towards the cathode. Copper is the least reactive, so that tends to be released. Now, we know that because we saw the deposit of copper on the cathode. And this would be reduction, just like before. So no change at the cathode. At the anode, we both get hydroxide and sulfate moving towards it. Now, what should happen this time, just like last time, is hydroxide should be released. And we should see bubbles of oxygen. In fact, we didn't see any. And so hydroxide can't be released. Sulfate wasn't released. But what happened this time was that the copper electrode dissolved. So it must go into solution as ions. So to do that, it loses 2 electrons. And this is called oxidation. Now, we will look at this process further and the implications of this for industry later on. So those are our electrolysis of solutions. They occur because the ions are free to move and carry the charge, and we can predict because of the reactivity series. Okay. Good luck with predicting the products of other electrolysis.